Okay, in this video we're going to look at generalizing our process and solving strictly algebraic inequalities. We looked at before solving more intuitive inequalities where we just had a simple expression that represented a tree growing or someone eating cookies or candy. And we were able to think through those problems using common sense, and we tried and connected it to using algebra. Now we're generalizing our process and strictly using algebra to understand the process for solving inequalities. So let's look at our first example, 3 times the quantity x minus 4. We want to know when is this going to be greater than negative 18. Okay, we know this is an inequality because we have an inequality symbol. Less than and greater than are inequality symbols. So that's why we call this an inequality. So just like before, our first step is we find our boundary point. Okay, that's when is it going to equal 18 or whatever, negative 18, or whatever the number is in that particular problem. We want to know when will the left expression equal that right number or the right expression. That's what finding the boundary point is. So we want to know when will 3 times the quantity x minus 4 equal negative 18. So at this point in the year, we should be good at solving equations, and if we're not, then we have to go back and review some of the other videos or resources. But for now, we're just going to go through this as quickly as we should be able to. So 3 times x is 3x, 3 times minus 4 is minus 12, and this equals negative 18. Again, we're just solving a basic equation. We add 12 to both sides to get rid of the minus 12, so we have 3x equals negative 6. We divide by 3 and we get x equals negative 2. So this means when x equals negative 2, our left expression equals negative 18. It's why we call it the boundary point. Okay, this is when it equals negative 18. So the next thing we do is we test points in a table. This is to help us understand the pattern this expression is following. What's going on before negative 2 or after negative 2. Negative 2 is the boundary point. So either before or after negative 2, all the values are going to be greater than or less than negative 18. Okay, if it's greater than before, it's going to be less than after. So we need to understand what's going on with this expression. So we have negative 2, it equals negative 18. So what is it when x equals negative 3? What is it when x equals negative 1? Okay, so we want to find all the values that are going to be greater than negative 18. So we substitute our numbers in for x. So negative 3 is x. We want to know what is 3 times negative 3 minus 4. What is this expression before negative 2 when x equals negative 3? So negative 3 minus 4 is negative 7, times 3 is negative 21. Okay, if we could start doing this in our head or just off to the side or on our calculator, that's fine too. We don't always have to write this step down. Okay, what about when x equals negative 1? So we do 3 times negative 1 minus 4. Negative 1 minus 4 is negative 5, times 3 is negative 15. So this table helps us organize what pattern this expression is following. Okay, so when x equals negative 2, it equals the negative 18. Okay, and that's our boundary point. So we want to find where is it going to be greater than negative 18? Is it going to be before negative 2 or after negative 2? Well, we understand at this point as well that negatives kind of work backwards. Negative 15 is greater than negative 18. So the numbers off to the right, the numbers that are greater than negative 2, are greater than negative 18. Okay, if we keep going, we find that 0 is negative 12. 1 is negative 9. Okay, all the numbers greater than negative 2 are going to give us the expression, a value that's greater than negative 18. And we use this table to figure that out. Again, we went off to the right because negative 15, the numbers greater than negative 2, the numbers after negative 2 are bigger than the negative 18 we wanted in the original problem. So our final thing is just kind of answer the question. Let's put this on a number line. Okay, we center it around our boundary point, and our boundary point is negative 2. Okay, the x values go on the number line. We leave it open because we want the numbers that are greater than negative 18. Negative 18 is not bigger than negative 18. So we leave this open, which means negative 2 is not part of the solution. And we want the numbers after negative 2. So we shade our graph to the right. Okay, this means every single number greater than -2 is a solution, including all the fractions and decimals in between. Every single number bigger than -2 is going to give us a value for this expression that's greater than -18. Now, if you look at these steps, it's really not that much, especially when you organize it so neatly. Okay, we solve our equation to find our boundary point, which we're good at doing, or we should be good at doing at this point in the year. We make a quick table. Again, this is something we should be good at doing at this point in the year. And the only thing that's new is kind of analyzing the table, figuring out what we want, and putting it in a number line and as an inequality. Okay, we found that -2 is our boundary point, so that's where we start. That's where we center our number line and where we put our circle around for our boundary point. And we realize in our table that the numbers after -2 give us a value bigger than -18. So we go off to the right and we say x is greater than -2. Okay, so why don't you try this one on your own. Okay, follow those same 3 steps, then press play when you're ready to check your answer and go over it. Okay, first thing is we find our boundary point. So we change this to an equation. We want to know when will this expression equal -50. Okay, we combine our like terms. -5x plus x is -4x. Minus 2 equals -50. We add 2 to both sides. We get -4x equals -48. We divide by -4. We get x equals 12. So now we set up our table around our boundary point. We know when x equals 12, we get out the expression equals -50. So we want to know what's going on before 12 and after 12. Okay, so when x equals 11, we do -5 times 11 minus 2 plus 11. This equals -46. Then we do 13. We do -5 times 13 minus 2 plus 13. This equals -56. Sorry, -54. Okay, so we want the numbers that are less than -50. Well, after 12 are the numbers that are less than -50, because we remember that negatives work backwards. So -54 is less than -50. Okay, when x equals 14, we get -58. When x equals 15, we get -62. So all the numbers after 12 are going to give us a value less than -50. So now we just put these on the number line. We center it around our x's. We have 10, 11, 12, 13, 14. This example, we have a closed circle because the or equals to means that this boundary point is part of the solution. Okay, the or equals to means we have a closed circle. We found in our table when we tested points, we want the numbers after 12. Those will give us values less than -50. We get x is greater than or equal to 12. Again, 3 simple steps. All right, let's look at the last type of example. Still the same process, but there's a little bit extra we have to do whenever we see something like this. So let's say we have the inequality 3x plus 7 is less than or equal to x plus 37. Okay, now we have variables on both sides, which we are going to have to take care of at one point, but the first thing is always the same. Let's find this boundary point. Okay, we want to know when will this left expression 3x plus 7 equal the right expression. And if you want, you could always try and think in terms of situations. Okay, maybe this person has $7 and is saving $3 each week, and this person has $37 and is saving $1 each week. Okay, we want to know when the first person is going to have less money than the second person. Okay, if you want to try and think of a real life situation to help you work through these problems, that's fine. But you have to understand that if we just stick through our steps and do it algebraically, we're still going to get to the same result. So our step 1 is we want to figure out when will the left expression equal the right expression. When will these two people have the same amount of money? Okay, so I'm going to subtract x from both sides, and I get 2x plus 7 equals 37. I'm going to subtract 7 from both sides, and I get 2x equals 30. I divide by 2, and I get x equals 15. Okay, so we have after 15 weeks, they have the same amount of money. Now this is where it's different. Okay, this step 2, when we're testing our points. Well, we're still testing our points in our table, but the thing is we're not comparing an expression to a number anymore. We're comparing two expressions. Okay, so we're going to have a little bit slightly more complicated table, but we have seen tables like this before. Okay, so we have after 15, or when x equals 15, both the left and the right expression are equal to each other. Okay, but we don't just have a number here, but we have to actually figure out, well, what do both the left and the right expression equal when x equals 15? And it better be the same. Okay, so in here, for our left expression, we do 3 times 15 plus 7, and that's 52. For our right expression, we do 15 plus 37, that's 52, which is good. That's our boundary point. So when x equals 15, both our left and right expression equal 42. They're equal to each other, which is fine. Okay, it's nothing new. We expected that. We needed that to happen. But now we just have a little bit more to test, okay? Because we're not comparing one expression to a number. We're comparing two expressions to each other. So we just have a little bit more substitution to do. But since we understood our steps before, this really isn't that complicated. So we want to know, what about when x equals 14? What's our left and right expression? How much money did the left person have after 14 days? And how much money did the right person have after 14 days? So for our left expression, we do 3 times 14 plus 7. This equals 49. For our right expression, we do 14 plus 37. And this equals 51. Again, this L and R is just your left and our right expression. Our left expression and our right expression. And for 16, what about after 16 days? How much does the left person have? So we do 3 times 16 plus 7. And this equals 55. And our right expression, we do 16 plus 37. So we just do x plus 37. And this equals 53. So now we want to know, when will the left expression be less than the right expression? Okay, so when is the left less than the right? Well, here 49 is less than 51. So that's when we're less than. Okay, 49 is less than 51. We're comparing our left expression to our right expression. So our final answer okay, our boundary point is 15. We're going to shade it in because we also want to know, when will the left expression equal the right expression, because we have the or equals to in our original inequality. And we're going off to the left. So before 15, before x equals 15, our left expression is greater than our right expression. And that's all we're comparing here. The only thing different about this problem was we had a little bit extra work to do when we were testing our points. We aren't comparing a number or an expression to a number anymore. We're comparing two expressions to each other. So we wanted to know, when will the left expression be less than the right expression? So we just substituted in. We found that 49 is less than 51. That's when x is less than 15. So we just graph it and we write our inequality the same way. X is less than or equal to 15. So still a simple process. We just have a little bit more work to do, but again, we're good at making tables and plugging in values at this point, so it shouldn't be a big deal. Okay, one more example for you to try on your own. So negative 11x plus 4 is greater than x minus 56. Press pause, try it on your own, press play when you're ready to check your answer and go over it. Okay, step 1, boundary point. Negative 11x plus 4 equals x minus 56. Okay, whenever you see an inequality, you change it to an equation to find your boundary point. Okay, I'm going to, let's add 12x to both sides. We have add 11x to both sides. So x plus 11x is 12x minus 56. I'm going to add 56 to both sides and get 60 equals 12x. Divide by 12 and we get x equals 5. So you should have found your boundary point. Even if you didn't solve it the same way, you should have found your boundary point to be x equals 5. Okay, this one we have a left and right expression. Okay, so we just need to make a little bit more complicated of a table. And we're not going to forget how to do the original tables Okay, when we're just comparing something to a number, but now we have a left and right expression. So when x equals 5, our left expression equals negative 11 times 5 plus 4, which is negative 51. And our right expression better also equal negative 51. 5 minus 56 is negative 51, which is what we expected. We better get that these two are the same, just like checking our answers when we're solving an equation. When x equals 5, both the left and right expression equal negative 51, which it should. That's our boundary point. So what goes on before our boundary point, what goes on after our boundary point. So negative 11 times 4 plus 4 for our left expression. This equals negative 44 plus 4 is negative 40. Our right expression, we do 4 minus 56, and we get negative 52. Okay, what about after? Again, if this could be done in your head or on your calculator, that's fine. Our left expression is we do negative 11 times 6 plus 4. Negative 66 plus 4 is negative 62. And our right expression, 6 minus 56, is negative 50. So now we have our table. We just want to figure out when will our left expression be greater than our right expression. Negative 40 is greater than negative 52. So before our boundary point is when our left expression is greater than our right expression. So we make our number line. We don't shade in our circle because we don't have the or equals to. We don't want to know when they're equal to each other, or we don't care about when they're equal to each other. We want to know, but we don't care, so we don't include it as our solution. And we found in our table that we care about the numbers, or we want the numbers less than 5 before our boundary point. So we say x is less than 5. So for more examples still, refer to the packet or some of the other online resources.